So now let's draw our root locus diagram. Imaginary axes, real axes. So let's plot the poles first. We're going to have poles at -4 and 0. So we're going to write them using x's, -4 and 0. And zeros here. So at -8 we're going to have 1 0. -8 we have a 0. Okay. Now, where do we have loci? This one. We're going to have locus loci if between either the poles or the zeros. So you take in between these ones, for example, if it's to the left, if the locus is to the left of an odd number of poles, in this case 1, poles or zeros. In this case we only have 1 pole, which is an odd number. So our locus is to the left of an odd number of poles or zeros, which means you can have a locus in between these 2 points. Can we have a locus in between these 2 points? Well, the locus is to the left of 2 poles or zeros, in this case poles, which is an even number, so no. And lastly, here, can we have one here? Yes, because the locus would be to the left of an odd number of poles and zeros. See here, this one's in between two poles. This one is starting from a 0 and is just going to go on to infinity searching for its pair. Poor thing. But why does it go off to infinity searching for its pair? Because we said here that in part 1 that the number of loci that go off to infinity is n minus m. In this case, n minus m. So 2 of our loci, we have 2 loci, but only 1 is going to go to infinity. So this one goes to infinity. Okay, so we've done this. Now, what's going to happen between the 2 poles? Because you have 2 poles, you know they're going to meet somewhere in the middle and then diverge. And then you have a complex conjugate pair. This is because they're two poles. So this is what happens at 2 poles. Where are they going to go off? You can find the angle at which they go off using this formula, 180 over n. In this case, n is 2. So 180 over 2 means 90 degrees. Plus or minus 90 degrees actually. So this one goes off at plus 90 degrees. And this one goes off at minus 90 degrees. From the real axes off into the plane. Okay. But are they going to go off all the way to infinity? No. They're going to, because they're breakaway points. But we established in part 1 that we're going to have break-in and breakaway points because we found two roots basically. So one is at -2. -2. This one. At -2. We said here we have 0 and -4 previously. So -2 is indeed going to be somewhere here where they break away. And then the other one was at -13. Here we said this 0 was at -8. So -13 is going to be somewhere here. So if we have breakaway points at -2, we're going to be having break-in points at -13. And that's basically it. You have breakaway point at minus 2.34 and break in at minus 13.66.